Hello, and welcome to Lab 1, Part B, Navigating with Sextant and Chronometer. The sextant. A sextant is a measuring device used to locate one's position north or south of the equator in latitude. Used at night, it measures the angle between the horizon and a circumpolar star. In the northern hemisphere, Polaris, or the northern star, is aligned directly above the North Pole. In the southern hemisphere, the Southern Cross, or the Southern Star, is aligned above the South Pole. For your lab assignment, you'll assume that the sextant measurements were all taken using the North Star. The chronometer. The chronometer is a precision timekeeping device used to determine longitude and the hemispheres of either the east or the west. Specifically, one's position and longitude is calculated from the time difference between your current time, taken at local noon, and the chronometer's UTC time. Because the Earth rotates eastward at a rate of 15 degrees of longitude per hour, we can use this ratio to calculate local longitude. For example, a 0600 UTC chronometer reading was taken during local noon. Thus, the difference between UTC noon and the 0600 chronometer reading is 6 hours. By multiplying the ratio of 15 degrees per hour, we can determine a position and longitude of 90 degrees. However, how do you know whether you're in the eastern or western hemisphere? The rule of thumb states that if the UTC chronometer reading is later than noon, then we're in the western hemisphere. Or if the UTC chronometer reading is earlier than noon, then we're in the eastern hemisphere. Thus, 0600 is earlier than UTC noon, so we're positioned at 90 degrees east. Use these examples to help you complete your lab assignment. Remember to assume that all sextant measurements are using the North Star. Also, use the ratio of 15 degrees per hour to calculate your positions and longitude. This concludes Part B of your lab section. Please address your questions to your lab TA.